So in this video, I'll be doing AMC 10B Spring 2021, 15, and 16. Now, number 15 is an incredibly annoying problem. Super, super annoying. I worked on this problem for so long. I have pages and pages and pages of work. Um, I could tell that this was a problem that has a trick. Like I just knew it. It just, this type of problem, when you see it, it just screams out trick problem, which is, again, kind of a shame. Not a huge fan of those kinds of problems, but they do come up, you know. Um, so basically, okay, so we're told real number x satisfies the equation x plus 1 divided by x is square root 5. What is the value of x to the power 11 minus 7x to the power 7 plus x to the power 3? Okay, so here's the thing. Okay, so now if we know that x plus 1 over x is square root of 5, we can square this. We can square both sides and get x squared plus 1 over x squared plus 2 equals 5, which tells us x squared plus 1 over x squared is 3. And now we can square this again and get x to the power 4 plus 1 over x to the power 4 plus 2 equals 9, or x to the power 4 plus 1 over x to the power 4 equals 7. So, which I knew, I've seen this trick before, so I know about that part, right? So the trick from here is to notice that if you look at the expression that we're trying to find, x to the power 11 minus 7x to the power 7 plus x to the power 3, you'll notice that there's some symmetry here, right? And you'll notice that like, how could I say it? So 11 is 4 more than 7 and 3 is 4 less than 7. So you have this sort of plus 4 and minus 4 here. So what that tells me is, what if I factor out x to the 7? So what if I take the expression we're trying to find and factor out x to the power 7? Right? I would be left with this, right? Which can be written like this: x to the 7 x to the power 4 minus 1 over x to the power 4 minus 7. But we just said that x to the power 4 plus 1 over x to the power 4 is 7. So we can substitute that with 7. So we're left with x to the power 7 times 7 minus 7, or x to the power 7 times 0, which equals 0. So our answer is 0. So I really don't like this problem. I feel like with every AMC, there's like at least one or two problems that I just don't really like. And again, it's because they have some trick involved to them, which I'm just not a fan of. Like I said, I tried doing a whole bunch of different methods, and it was just kind of getting me nowhere. But yeah, so yeah, not a huge fan of this problem, but it is what it is. The next problem is significantly easier. So we're told, call a positive integer an uphill integer if every digit is strictly greater than the previous digit. For example, nope, let me move this up. For example, 1, 3, 5, 7, 8, 9, and 5 are all uphill integers, but 3, 2, 1, 2, 4, 0, and 4, 6, 6 are not. How many uphill integers are divisible by 15? So to be an uphill integer, every digit has to be greater than the previous digit. So 1, 2, 3, 4, or 1, 2, 5, 7 would all be considered uphill integers, right? Now, notice how in order for a number to be divisible by 15, it has to be divisible by both 3 and 5. So think about your divisibility rules. How do we know if a number is divisible by 3? A number is divisible by 3 if the sum of its digits is divisible by 3, right? So if the sum of the digits is divisible by 3, the number is divisible by 3. What about divisibility by 5? Well, divisibility by 5 means the number ends in a 0 or a 5. Okay. But now notice that a positive uphill integer cannot end in 0. Right? That wouldn't make sense, because how could it end in a 0? Then it could only be 0, which isn't positive. So we know our number has to end with 5, which makes our jobs a lot easier. right? Because there's really only 4 digits that are less than 5. Now we just need the sum to be a multiple of 3. Well, let's think about it. 5 is -1 mod 3. So hopefully you guys have some understanding of modular arithmetic. Basically, it just means that 5 is 1 less than a multiple of 3. So that means that whatever we add, we need that sum to be 1 mod 3. So we need to add 1 more than a multiple of 3 in order for the sum to be a multiple of 3. So what kind of numbers are 1 more than a multiple of 3? 1, 4, 7, 10, 13, etc., right? But notice that 1 plus 2 plus 3 plus 4 is 10. So it can't be 13 or higher. So we need to look at ways that we can form those 4 numbers. Well, how can we form 1? The only way to form 1 is just with 1. So we know 15 is one answer, right? How can we form 4? Well, we can form 4 by using 1 and 3. So we can have 1, 3, 5. Or we could just have 4, 5, right? Just put 4 in front of the 5, right? How many ways can we make 7? We can make 7 by doing 3 and 4. So we have 3, 4, 5. Or 1, 2, 4, 5, right? 1 plus 2 plus 4 is also 7. So that's another one that can work. And then how can we make 10? We can make 10 by adding all of the numbers together. 1, 2, 3, 4, 5. Well, 1 plus 2 plus 3 plus 4 is 10, right? So 1, 2, 3, 4, 5 would be divisible by 15, right? And there's no other way to make 10 because that's the sum of all the numbers. So that means we've exhausted all our possibilities. So there are 1, 2, 3, 4, 5, 6 possible ways, 6 possible uphill integers that are divisible by 15. And again, you guys know I love number theory, so these are my favorite types of problems. These and geometry. Geometry and number theory are typically my favorite problems. So, all right, see you in the next video. I'll do 17 and 18, and I will see you there.